Have you ever seen God directly? Maybe the answer is definitely not. But in fact, we all are witnessed to watch a visible God daily. The name is Sun. Sun is the visible God and he produces green energy. He is the prominent source for continuous energy. And today topic is photovoltaic cell. This is the ninth video under fears. You can watch all my previous videos in my YouTube channel. The corresponding links are provided in the below description. So this photovoltaic cell come under non-conventional energy sources and is also renewable and sustainable energy sources. So what is non-conventional energy sources and what is conventional energy sources? From long back onwards, we are using traditionally the energy sources like coal, LPG, petroleum products. These are called conventional energy sources. So newly, alternative for conventional energy for resources is called non-conventional energy sources. Example: solar energy, wind energy, tidal energy, hydropower, biofuels. These all are the non-conventional energy sources, and also these are renewable energy sources. So what is the differences between conventional and non-conventional energy sources? So if you see here, the world petroleum reservoirs or fossil fuel reservoirs are going to decline. We need to search for alternative fuels for fossil fuels. Those are called non-conventional energy sources. The conventional energy sources are not renewable. Renewable means renewable. That means it can be produced again and again, and newly we can produce again and able we can do. So we can produce this energy again and again. We can, even though we can use at that moment completely, we can produce again and again. That type of fuels is called, that type of energy sources is called renewable energy sources. Non-conventional energy sources are renewable energy sources, but conventional energy sources are non-renewable energy sources. Once you completely use the reservoir of the petroleums, it will take lot of time to produce again the petroleum products or fossil fuel products. Okay, so it will be exhausted at one day. It will be exhausted at one day, but non-conventional fuels are continuously available. For example, solar radiation, every day sun will come, it will come with lot of energy. We can use as much as we can. So conventional energy sources necessary to conserve. We need to we need to protect, and we need to aware the how we can use it. So limited usages, and we need to definitely conserve the conventional sources. But non-conventional energy sources are no need to conserve. Again, tomorrow they will come. Wind will come every day. So water flow and tidals, these are the no need to conserve. They are continuously available. So and also conventional energy sources are causes for the more pollution. But most of the times, non-conventional energy sources produces the less pollution or sometimes pollution-free fuels. So these are the main differences between the conventional energy sources and non-conventional energy sources. And today topic is photovoltaic cell. This is energy produced by the solar radiation. Solar radiation is a non-conventional energy sources, it's a sustainable energy sources, and also a renewable energy sources. Okay, so what is solar energy? Solar energy is the radiation energy which is emitted by the sun. So due to nuclear fusion reactions in the sun surface and atmosphere, they produces a lot of energy. That energy is called solar radiation or solar energy. So these solar energy can be converted into many forms of energy such as heat and electricity. So how can we generate the heat and electricity is our topic. These are the renewable energy sources. They produces cleaner energy source. They produces cleaner energies, and they decreases the dependency on fossil fuels. That's why these are the alternative for fossil fuels. And also because of photovoltaic cells, the nation economy also increases. Why? Because the dependency of fossil fuel decreases mean we are depending on other countries. Why? Because for example, India doesn't have any much oil sources or fossil fuel sources. So we are depending on other country, definitely our economy will decrease. If only we produces the photovoltaic cell, we produces the electrical energy, we can increase our nation economy also. So what is photovoltaic cell? So photovoltaic cell is a device. So it is a device which produces the electrical energy, by using solar radiation and photovoltaic cells. Very simple. It is a device which produces electricity by using the solar radiation and photovoltaic cells. So in this there is a only two components here. One is energy source, that is solar energy, and a device, that is a semiconductor, which converts the solar radiation into electrical energy. So that is the semiconductor device. So if you want to know the photovoltaic cell, first of all you need to know what is semiconductor devices. So semiconductor device. Let's see the construction of photovoltaic cells. So photovoltaic cells are made by semiconductor materials such as doped silica materials. We know what is semiconductor, what is conductor, and what is insulator. Semiconductors mean the conducting properties of materials lies between conductors and insulators. In special conditions, semiconductors may act as conductors or they also act as the insulators. The conductivity depending on the surrounding condition like atmosphere, pressure, like these conditions. Okay. So for example, if you take a silica material, pure silica material, silica have a valency 1s2, 2s2, 2p6 and 3s2, 3p2. The valency shell, that means last electrons occupied cell, called valency cell, it having a four valency electrons. So this four valency electron involved in covalent bonding with another four silica atoms. So like that, this silica having one electron and this silica also having one electron, both are combined each other form a covalent bond here. Like that, every silica atom forms four covalent bonds with surrounded four silica atoms. The silica, there is no free electrons in it. But at the room temperature, these bonds will break down and they produces the free electrons. Now it can able to conduct electricity. That means at room temperature it acts as a conductor. At a 0 kelvins, so because of lower temperatures, bonds are very strong. That situation it acts as an insulator. That means pure silica can act as conductor and also act as insulator. The conductivity is dependent on temperature. That's why pure silica is called semiconductor. Example for semiconductor like germanium also example for the semiconductor. Semiconductors are two types, intrinsic semiconductor and extrinsic semiconductor. Pure semiconductors are called intrinsic semiconductors, but in photovoltaic cells, we need to use a doped silica materials. Those are called extrinsic semiconductors. So what is this extrinsic semiconductor? There are two types of extrinsic semiconductors. One is N-type semiconductor, another one is P-type semiconductor. So let's see here. So now this is the pure silica material. This is the pure silica material. So I can do one thing here. I want to replace one silica atom. So I want to replace one silica atom here. Give me 1 minute. So I want to replace one silica atom with one phosphorus atom. Okay. So phosphorus electronic configuration, if you observe here, 1s2, 2s2, 2p6 and 3s2, 3p3. This is the valency electronic. This is how many valence electrons is there? 5 valence electrons is there. Now what I am doing here, I am just replacing the silica with phosphorus. So I want to replace one of the atom of with phosphorus. Phosphorus having 5 valence electron but surrounded by only silica atoms only. Now this phosphorus make 4 bonds with the 4 other silica atoms. Still it have a 1 electron. So like that, if I replace some of the silica atoms with 5 valency electron phosphorus, it's generate more free electrons within the material. Because of electrons have a negative charge, they are easily conduct electricity than the intrinsic pure silica material. These are called N-type semiconductor. N stands for negative. Because of phosphorus having fifth valence electron, because of the fifth valence electron, it's generating negative charge within the metal. That's why it is called N-type semiconductor. The second case, now I want to replace pure silica atom with boron. Boron having a 3 valency electron only. If boron atomic number is 5, 1s2, 2s2, 2p1. Second orbital is a valence orbital. It having 3 electrons. So now if I replace the boron, it only having 3 electrons only. So not fourth electron. Here there is no fourth electron. So because of this, there is a empty hole is there. Empty hole is there. It only 3 valence electron. It can form only 3 bonds with the other silica atoms. In another side, there is a free hole is there. So this hole is represented as positively. That's why these type of semiconductors is called P-type semiconductors. These are the how can we generate the N-type semiconductor and P-type semiconductor from pure silica material. So these are called extrinsic semiconductors. By using these extrinsic semiconductors, we can produce a semi uh, we can produce a semiconductor device that is used in the photovoltaic cell. Let's see here. So when I doped with the phosphorus atom or 15th group element, like phosphorus, it produces the number of electrons in the metal. So that's why it is called N-type semiconductors. When you dope the pure silica metal with the boron, 13 group elements like boron, it produces a more positive charge in the metal. It is called P-type semiconductor. Now the most beautiful thing is when you combine N-type and P-type each other. When you move N and P type to closer, then what will happen? A depletion layer formed. That depletion layer is called an P-N junction diode. P-N junction diode. When you move N type and P type to close, so when you attach the N type and P type each other, the boundary between N type and P type forms as a depletion layer. This is called P-N junction diode. So what happened here? If you observe the n-type, it has a more number of negative charges. Yes, has a more number of negative charges. But when you form the p-n junction diode, there is a positive charge layer just above the depletion layer. Just above the depletion layer in n-type semiconductor. Actually, n-type semiconductor have more negative charges. So those negative charges is there. But there is a positive charge layer is formed just above the p-n junction diode. Okay, next one. So generally p-type semiconductor have more positive charge. So positive charge is there. I'm not showing here. So but positive charge is there. But there is a negative layer. There is a negative layer formed just below the p-n junction diode in P-type semiconductor. So like this p-n junction diode form. Why it is formed like this? If you imagine the war scene in the movies, there is a two sides of army is ready to face each other. When the war is started, both are running towards each other, and where they are meet, they are killed each other. They are killed each other, and some of the right side soldiers move towards the left side. Some of the left side soldiers move towards the right side. After some time, if you observe from eye angle, some of the both armies are died between the where they met. Okay, died where they met, and some of the A side soldiers moving towards B side soldiers moving to the A side. Just like imagine that one and apply to here. This is the A side soldiers and this is the B side soldiers. When they are met each other, they are killed each other. That means A plus charge and minus charge both are nullified. That's why here both are nullified. There is no charge in the depletion layer. So all positive and negative charges are combined each other. That means both charges are nullified each other. And some of the negative charges are moved this side. Some of the negative charges are moved this side and forms a negative layer here. Some of the positive charges are moved upside and forms a positive layer here. This is called PN junction diode. The formation of PN junction diode is the very important. This is the driving force to generate the electricity. So this is the this is the driving force to generate the electricity. So how electricity will produce? See here, this is the PN junction diode. So just you prepare the N-type semiconductor, P-type semiconductor. When they adjacent together, it forms a PN junction diode. And you just keep a external wire from P-type N-type semiconductor to P-type semiconductor. One external conducting wire you are also made here. This is the external conducting wire. Okay. So now, when you kept this PN junction diode towards the solar radiation, sun energy, so when the sufficient sun energy fallen on the depletion layer, at the depletion layer, positive charge and negative charge combined each other. The charge is nullified, neutralized. When the solar radiation is passed over these combined electrons, these electrons gets energy, and now these positive charge and negative charge separated each other. See here, when the solar radiation is fall down on the PN junction diode, this positive charge and negative charge separated each other. So now this positive charge wants to move one direction. If you observe here just above, there is a positive layer is there. That's why this positive charge cannot move upside because of repulsion forces. So now, so this positive charge can easily move towards the downside. Okay, that means the positive charge generated in the PN junction diode moves towards P-type semiconductor, right? Yes. Next one. The negative charge generated in the PN junction diode wants to move downside, but there is a negative charge layer is there. So because of repulsion forces, this movement is not happen. It easily can move to upside. That is called it. That is, it's moving towards the N-type semiconductors. Like that, so many electron hole pairs are divided, and some of the electrons are moving towards the N-type semiconductor, and some of the positive charge holes are moving towards the P-type semiconductor. So already N-type having electrons. So because of this movement, number of electrons is increased. That means electron density is increased at the N-type semiconductor. So P-type semiconductor also having positive charges before, and because of this movement also number of positive holes is generated. So totally positive charge density increases. That means, so here charge separation takes place. One place more negative charge, one place more positive charge. So when the charge separation takes place, now electrons are forced to move one place to another place to decrease the charge separation. So if electron cannot move like this, why? Because there is a depletion layer is there. That's why electron cannot jump like this. So that's why when you kept a external wire, so now electrons are drawn from the N-type semiconductors, and they move from N-type semiconductor to P-type semiconductor to meet the positive holes. This movement, the movement of electron from one end to another end, is called electricity. So it produces the electricity. This movement, this potential difference, charge separation generates the potential difference. That potential difference produces the electricity. Like that, we can generate the electricity by using PN junction diode by using the solar radiation. By using the solar radiation and PN junction diodes, we can produce the electricity. So the simple thing is, so we are only making a PN junction diode. PN junction diode is driving force to move the electron from one place to another place. Okay. So for example, if I keep only P-type semiconductors or N-type semiconductor, N-type semiconductor having more electrons here, minus, minus, and minus. So now if I connect an external wire like this, I'm not making a PN junction diode, only N-type semiconductor is there. I'm kept this N-type semiconductor towards the solar radiation. Now solar radiation is passed over the N-type semiconductor. There is a number of electrons is there. Because of solar radiation, heat energy generated. So this get a kinetic energy. So now also electrons are moved like this to this way. It is also produce electricity. Is it possible? It possible, but it produces very, very, very low energy. Why? Because these electrons, why they move like this? Why they move this direction? No one is directing to go like this way. They can move any direction. They can move like this direction. So the movement is very random. They can move anywhere. So what is the necessary to move through the external wire? Though there is no driving force in the a single semiconductor materials. Okay. So, but when you make a PN junction diode, it's moving electron upside. So, because electron density increasing here positive charge increasing here. So, charge separation is takes place. Potential difference occurs. Now, electron cannot move this direction. So, only way is electron has to move this direction to reach this one. Okay. So that's why here PN junction diode creating a some driving force to move electron from n-type to p-type semiconductors. So this is the total what I explained up to now. So there is a potential difference exit between the two layers because of charge separation. So this can electrons are moved from n-type to p-type through the external circuit. This is called p-n junction diode working. So what is the advantage and disadvantage of the solar cells? Solar cells are environmentally friendly. They are doesn't produces a harmful gases. They are considered as a green energy. These are renewable, so we can use again and again. They are infinite. There is no finite. There is infinite sources, so that means continuously we can use every day. So they reduce your power bill, and also innovative, it is an innovative technology that long life solar panels, if you once you install, they are continuously work 20 years without any trouble. So disadvantage is solar seasonal energy. So sun will not come on the springer and winter time, and high investment you require to install the solar panels, and installation also very difficult. It occupies the more land, and location sensitivity. Some locations sun will come continuously, some locations will not come. That's why location and time sensitive also. Night time also sun will not come. So you need to store the energy when you are producing excess energy. That's purpose you also need excess expensive batteries. These are the disadvantages. So but advantage is there. Still research work is continue to enhance the quality and production of the solar radiation. This is our topic. Thank you for listening with me.